Next semester, you're planning on taking 3 courses, 1 math, 1 English, and 1 humanity. There are 8 sections of math, 5 of English, and 4 of humanities that you find suitable. Assuming no scheduling conflicts, how many different 3-course schedules are possible?
320.
40 times 4, right? 40 times 4.
It would end up being, yeah.
160?
It would end up being 160. So,
Oh, I doubled that. My bad.
yeah. So, to find that, what Keelan did to find 160 is in his head he multiplied 8 times 5, got 40 from that, and then he multiplied it by 4, which would give you 160 different options. So the important thing that they mention on here is that they mention there's no scheduling conflicts. Obviously, in a normal situation, there'll probably be some scheduling conflicts, which is actually what can make this more complicated as we get going further next week.
Like,
So we're done with the other stuff?
We are done with the other stuff.
like so, there could be a problem that says you can do these things, but you can only do this one if you do this one or something.
Correct.
Like
That's what we're going to start seeing next week.
Insert quote?
Okay. Let's take a look at this next example, because this is where it starts to can be tricky. So it says you're taking a multiple choice test that has 10 questions. Each question has 4 answer choices with 1 correct answer per question. If you select one of these 4 choices for each question and leave nothing blank, in how many ways can you answer the questions? How do I find the amount of ways that I'm answering the questions here?
What do you mean if you select?
25%, right?
10 times 4.
Okay, so Sophia suggests that we can do 10 times 4. So I'm going to write this down here.
And then what is
This is
So it tells us that we have multiple choice test with 10 questions.
well, it says select one of 4 choices, then it says leave nothing blank.
So if we go here, well, you're right. You're thinking along. So Sophia suggests that we can do 10 times 4. This is actually incorrect.
That's just
Why is it
impossible.
incorrect?
That's just the possible answers, including the wrong one, right?
So that is actually how many. That is the total of basically total of the bubbles that you can fill out, because there are 40 possible bubbles. But
Is it dividing?
what Jeff is pointing out there is that technically each of these questions has its own options. So when you're actually looking at a problem like this, what Sophia answered was actually what I was looking for somebody to do, because that is the mistake that always gets made, which is good. Everybody makes that mistake on this one. So I was actually fishing for that answer. What you have to be careful about is up here we had things that were clearly separated by being different types of things. We had 8 sections of math, so that was math was one of our pieces. We had 5 of English and 4 of humanities. So that told us very clearly that we had 3 different things that were being combined. Here it's not as clear, but what it does mention is that we have 10 questions that have 4 answer choices each. So what we actually have is 10 4 option questions. So it's actually
What? It's like 4 to the 10th power?
it's 4 to the 10th power, because there are 10 questions that have their own options. So you could think of maybe the first question being about math, second question being about English, third question being about humanities, and so on. There's actually 4 pieces there's actually 10 pieces that you need to multiply by each other that have their own options. So this would be question 1, this is question 2, question 3, question 4, question 5, question 6, question 7, question 8, question 9, and then question 10. Then if you collapse those together, like Jeff said, it's 4 to the 10th power. So this is why I was saying you want to be careful with these, is because while it's all just multiplication, you have to make sure you know how many items you actually have being multiplied together. So if you actually do that, 4 to the 10th, it ends up being, so I'm going to rate this.
It's 4 to the 10th power or 10 to the 4th power?
4 to the 10th power, because we have 10 fours being multiplied by each other.
There's no way. That's seriously 1 million.
Mm-hmm. So there's something I want to point out about this.
48,576.
Mhm.
That's ridiculous.
So the answer to this is 1 million. There are 1,048,576 ways that you could possibly answer. Choose one answer on this for each question on this multiple choice test. So something I want to point out for those of you that have completely guessed on a multiple choice test before, which I would say at some point in everybody's life they may have at least guessed on part of one.
So you're saying if we had a 10 question quiz, if we answered one question is like 1 in a million of getting it right?
Yeah.
Correct.
Mr. Rickers?
Yes.
Oh.
Yes.
Sophia Hughes.
Sorry, say again?
I'm Sophia Hughes.
Yes.
Office for just a moment, please.
Okay.
Aw.
All right. So yes, what Jeff was just pointing out is actually something that's really kind of interesting about this question. If you were to completely guess on a 10-question test that was multiple choice and had 4 options each, only one of those 1 million options is actually going to be completely right. So you have a 1 in 1,048,576 chance of actually guessing all of the correct answers on a test.
So it's like on Dumb and Dumber, and you're saying there's a chance.
There's a chance. It's not a good one. All right.
What's the question?
Any questions about this one? Anybody unsure where we got all those 4s? Okay, this last one's actually similar, but it adds in another restriction. So this one's a little bit, it's the same idea, but it's a little bit more complicated even. So the example, it says telephone numbers in the United States begin with a 3-digit area code, followed by a 7-digit local telephone number. Area codes and telephone numbers cannot begin with a 0 or 1, which is actually true. That's true about how phone numbers work. You will never have an area code or a local telephone number that begins with a 0 or 1. How many different telephone numbers are possible?
Okay. 3.
How would I go about solving this?
I don't even know, dude.
It'd be 3 times 8, right? For the area
So
code.
there's 8 numbers?
Yeah, so it'd be like, no, it'd
Or
be
3
like,
to the 8th power?
it'd be 8, right? 8 times 8 times 8.
So you're close. So let's just look at the area code to start. So that's what Keelan was talking about here. Let's look at the area code to start. So what I like to do is I like to actually write boxes for these. And I'm actually going to do these in 2 colors. I'm going to have one box, which is the first box being blue. And then the second 2 boxes of the area code, I'm going to have them be green. Even though you really can't tell that well up here because the bulb on this projector kind of sucks. So we have one blue box and then 2 green ones. Why is this one? Why did I color this one differently?
Because that one can't be a 1 or a 0.
Can't be a 1 or a 0. So
Oh.
what Keelan was saying is that there are 8 possible digits. Because if it can't be a 1 or 0, that means it can be 2. It can be a 2, 3, 4, 5, 6, 7, 8, 9. So there's you have 8 possibilities for numbers there. So the first box would be 8. But what are the second 2 boxes on there?
11 times
You have 10 possibilities.
You have 10 possibilities there. Because it
Wait.
can be 0 through 9.
Oh, yeah. Yeah.
Because it's only the first digit of the area code that cannot be a 0 or 1. But on the other ones, it can be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, which is 10 possible digits.
So what, you do 8 to the 3rd power, then 10 to the 3rd power, then 10 to the 3rd power?
So we wouldn't need powers for this because we're actually just going to be multiplying these together. So it'd be 8 times 10 times 10. Similar to here, where we had 4 times 4 times 4, except for in this case, all of the options had the same amount. Here they vary a little bit. But that's just the area code. We still have to deal with the normal part of the telephone number.
800 is the first
It'd
one?
be 8.
Well, it'll be 800 then times 10 again, so it's actually 8,000 in that
But
section.
10
Oh shoot, that's not.
times 8 is only 80 though, right?
Mm-hmm.
Then you times that by
Oh yeah, you're right. I actually did mess up the calculation on this earlier.
Yeah,
So-
It was a circle.
So I'm going to go ahead and write out, because the part of the local phone number has 7 digits. It has 7 digits here. So we dealt with the area code. The local phone number has a similar restriction on the first number. The first digit on the telephone, on a normal telephone number, also can't be a 0 or 1. So it's going to have that same 8 possibilities that the first one there did. Then the rest of them, again, can also be 0 and 1. Or, sorry, they can have 0 and 1. So these are all going to be 10s. So if we actually, what I suggest doing on this, something you can do to actually make it so you don't have to type out 8 times 10 times 10 times 8 times 10 times 10 times 10 times 10 times 10 times 10. You can actually combine these up into using exponents. So you could take the 8s and make that 8 squared. Then combine all the 10s into one single thing. We have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 10s, so it's going to be 10 to the 8th power. That way, to make it a little bit cleaner. Then when you plug in your calculator, you can do 8 to the 2nd power times 10 to the 8th power. And you end up with, I'm pretty sure it's 6,400,000,000.
Alright, I'm gonna do them with the calculator real quick.
Yeah, it ends up being 6,400,000,000 possible phone numbers.
What?
So is that like 6.4 to like 10 to the whatever? Could we write it like that or no?
You could do that, yeah. If you wanted to put it, if you wanted to use scientific notation, that'd be fine. Yeah, if you wanted to shorten this and use scientific notation, that'd be fine.
Not yet.
So we have so just in the U.S., there are a possibility of 6.4 billion phone numbers. Now, that's just in the U.S. This is actually the U.S. limitation. How many of you are familiar with the number that goes in front of the area code occasionally? The 1. So that 1 is actually the country code. For the U.S., our country code is 1. If you were, and Canada actually usually get by this, usually don't need it. But if sometimes you're dialing a phone number in Canada, you'd have to put a 2 in front of it because Canada's country code is 2. I think like the UK, I think if you were calling UK, I think it's 16.
So we're number 1.
So well, that's because phones were.
I was gonna say, I guess it couldn't be 1 through 10 because there's more than 10 countries.
Yeah, exactly. So they actually do go up in digits. So this is actually the total number of phone numbers for the U.S. alone. For the U.S. alone, there's actually several multiples more possible in the rest when you're talking about the rest of the world. So there are actually more humans than this on the Earth, but there's not necessarily everybody has a phone number, and some people have multiple phone numbers. So
wait, that's 6 trillion or
6 billion.
billion? Okay, yeah.
6
okay,
billion.
billion.
But when you start talking about country codes, it does actually get into the trillions for different possibilities.
Well, that's pretty good then.
Yeah. We have a lot of room to grow on phone numbers. Any questions about this one?
Well, not with beans now.
Wait, what? What'd you say? Boy, you hear?
Any questions about this?
Might answer later if I forget.
We just said that.
You will.
Why?